Hello, my good people. Welcome and thank you for joining Jose Renegade, where we get to share facts, theories, and knowledge in general. And today we're going to be talking about the planet Earth. There are few too little information that we know about our home, and I would like to share basic information that maybe information that some of you might find relevant and helpful. Let me start off by saying four planets in the solar system are smaller than the planet Earth. Four are considerably larger. The Earth, therefore, is not an outstanding member of the vast solar family. However, it is the most important of all planets to you and me, for it is our home in space, the vantage point from which we view the universe. Many theories have been proposed to explain the origin of the Earth and the other planets. They are little more than ingenious conjectures, for they are based on insufficient data. However, though we know little about the origins and beginnings of our planet, we know a great deal about its shape, structure, properties, and motions. We are quite certain that the Earth is round or nearly so. Photographs of the Earth taken from the rockets soaring above its surface showing distinctly the curvature of our planet. Before this factual evidence became available, we could infer the roundness of the Earth from certain facts. It was known, for example, that the hull of the descending ship following the curve of the Earth disappears from the view before its superstructure does. The diameter of the Earth is 7,900 miles from pole to pole, and it is 7,927 miles in the horizontal zone. The difference between the diameters is comparatively slight, therefore, it comes to a little more than one part of 300. If the Earth were represented by a globe 18 inches in diameter, the polar radius would be one third an inch less of the equatorial radius. Someone has said that the Earth is more nearly a sphere than most of the balls you would find in a bowling alley. The mass of an object represents the concentration of matter in it. It is the constant value. In the respect it differs from weight as well, we shall see in measure of gravity and changes from place to place. Various methods have been used to find the mass of the Earth. About 1735, the mathematician Pierre Bouguer, while in Ecuador, measured the extent to which a plumb line was deflected by the gravitational pull of a mountain. Since he could estimate the mass of a mountain, he was able to estimate the mass of the Earth after the deflection was measured. A sensitive instrument called the torsion balance is generally used in modern times to determine the Earth's mass. Earth is made up of three parts: air, the water, and the solid part, or a scientist would say the atmosphere, hydrosphere, and the lithosphere. The atmosphere, we do not know how far up the atmosphere goes. However, auroral displays have been observed in the altitude up to 300 miles and 600 miles, and therefore the atmosphere must extend at least that far. The lower layer of the air envelope is a troposphere. Tropos meaning change in Greek. The troposphere is the region where great changes take place in the temperature, pressure, and water vapor content of the air. It is the part of the atmosphere where our weather occurs, although most atmospheric changes take place relatively close to the Earth. The troposphere extends to its altitude of about 7 miles. At the outer limit of the troposphere, there is a zone of division between the troposphere and the next sphere. It is called the tropopause. The next atmospheric layer, extending from what 7 miles up to some 50 miles above the surface, is stratosphere. Temperature in this zone drops to a fairly constant 67 degrees Fahrenheit below zero. It is the zone of a strange, little understood fast-moving streams of air which may reach velocities of 250 miles per hour. As we travel away from the Earth, we go through the stratopause and enter the ionosphere, which extends for several hundred miles. This region contains ions, atoms that have been stripped of some of the electrons. Radio waves of different lengths are reflected back to the Earth by different layers of the ionosphere. It is in the ionosphere that there arise brilliant displays called auroras or northern lights in the northern hemisphere, and the aurora australis or southern lights in the southern hemisphere. The air pressure here is extremely low, from only 0.065 of a pound per square foot at the lower level. The lower part of the ionosphere absorbs much of the ultraviolet energy of the sun. If this did not happen, the ultraviolet rays of the sun would destroy life on the earth. Some ultraviolet does penetrate the ionosphere and reaches the earth's surface. It helps build up vitamin D in our bodies. It also causes sunburn. The Earth appears to be the only planet that contains large amounts of water. About three-fourths of the surface is covered by the oceans. These bodies of waters, together with large inland lakes, contribute great amounts of vapor to the air. They play a large part in the atmosphere changes that we call weather. Almost 96% by weight of the waters of the earth are made up of hydrogen and oxygen, sodium, chlorine, and many other elements also found here. In fact, traces of all chemical elements would probably be revealed if instruments with enough sensitivity were used. The plants and animals found in the sea are immensely valuable resource. They provide man with food, fertilizers, and industrial materials. The ocean is also a vast storehouse of minerals such as common salt, magnesium, gold, iron, copper, uranium, and silver. Some of them, such as salt and magnesium, are obtained from the sea in quantity. Others will no doubt be made available to mankind as more efficient methods for extracting them are developed. The solid part of the earth is made up of three types of rock: igneous, sedimentary, and metamorphic. Igneous rock is derived from the molten rock producing matter called magma. Sedimentary rock consists principally of rock fragments that have been accumulated through untold millennia and that have been pressed together. When igneous rock or sedimentary rock becomes altered through changes in temperatures and the pressure and other forces within the earth, it gives